Okay, so 6a. Okay, so for each of the following, use the fact that g of 5 equals 3, -3. G prime of 5 equals 6. H of 5 equals 3. H prime of 5 equals -2. To find f prime of 5 if possible. If it is not possible, state what additional information is needed. Okay. Let's see here. What the heck is this? Okay, so they give us a bunch of information. What they don't tell us is what g of x or g of t, or they don't give us the actual function, but they tell us the answers. They say, hey, there's a function. There's a function. It's called g. When I plug in 5, I get -3 as an answer. When I take the derivative of that and plug in 5, I get 6 as an answer. When I plug in, and then there's h. When I plug in 5 for h, I get 3 as an answer. When I plug in, and then when I take the derivative of h and I plug in 5, I get -2 as an answer. So they've given me a bunch of information. So anytime they do that, make a table. Make a table. Sometimes they'll give you the table. Sometimes you have to make the table. It's a way to organize your thoughts, the information they've given you. So they've given you information on 2 things. They've given you information on actually 4 things. G, G prime, H, and H prime. They've given you information on all 4 of those. What X value have they given you information about all of those on? 5. So we're going to put the 5 over here. Okay. So what they've said is, when I plug in 5 to G, I get -3 as an answer. Okay. When I plug in 5 to the derivative of G, I get 6 as an answer. When I plug in 5 to H, I get 3 as an answer. And then when I plug in 5 to H prime, the derivative of H, I get -2 as an answer. Okay, so essentially it's saying the same thing as what the prompt is saying, but it's a little more clear. So the first thing they want you to do is find this. That's what they want you to do for each of these. Okay, for each of these guys, they want you to find f prime of 5. Okay, so the first one, A, here's f. We have f. It's right here. They want us to find what this is equal to. So what's the first thing we got to do if we need to find f prime of 5? What's the first thing? Mm-hmm. What's that? I do have it. But what do I need to do this? To do this right here. What is this command telling me to do? So in other words, what is this command right here telling me to do? It's a command. It's saying do this and give me the answer. What is that command? Yes, Shrishti? There you go. That's the 2 things. It's saying I need to find the derivative of f. That's the first thing it's saying. And then the second thing it's saying is once you've done that, input 5 and give me an answer. Okay? To do those 2 things, I need the derivative first. I can't input 5 unless I know the derivative. Well, here it is right here. Oops. Here's f right here. F is g of x times h of x. So if I'm going to find the derivative, how do you think I'm going to, what are the methods, what are the rules I'm going to use to find the derivative? What do you think I'm going to do? How do I find derivative for this guy? Yes. Product rule. Yep. I have this guy times this guy. That's product rule. Now, I don't have the actual function. I don't know what g of x equals, and I don't know what h of x equals, but I know what I'm going to do, right? The product rule says you take the first one, so rewrite the first one. You multiply that times the derivative of the second one. And then you add the second one times the derivative of the first one. That's what I would have done if I would have known what g and h are. I don't know what they are, but that's what I would have done. That's as far as I can go, right? That's the derivative. That's f prime right there. F prime is equal to that. That's what it says. F prime is equal to this. Derivative check. What was the second command I needed to do? Plug in 5, input 5. So everywhere I see an x, I'm going to input a 5. G of 5 times h prime of 5 plus h of 5 times g prime of 5. Do I know what each of these guys' value is? Yeah, the table told me, right? Didn't the table tell me? The table told me each of these guys what they are. G of 5. They said g of 5 is -3 times h prime of 5. H prime of 5, the table says, is -2 plus h of 5 is 3. G prime of 5 is 6. When we multiply and add, what do we get? 6 plus 18 is 24. Done. G f prime of 5 is 24. We would have done the same thing up here, right? For these guys. If they said find f prime of 5, we would have done the same thing. I would have found the derivative, which is in yellow, and then everywhere I see here, I would have plugged in a 5, right? And then I would have gotten an answer. They just didn't ask me to do that. So you're doing the same thing. It's just you're using the table instead of using a function. Okay? All right, so let's do B. B is the same question. B is exactly the same thing. They want f prime of 5. It's not going to give me the same answer because it's a different function. It's not g of x times f of x. How am I going to find derivative of this guy? What am I going to use? Chain rule. That's the definition of the chain rule. The chain rule, h is inside of g. That's a chain rule problem, right? That's a chain rule problem. So we have two functions. I have an outside and I have an inside. So just like I did yesterday, let me highlight them. The outside is g. The inside is h. So the first thing I have to do is find the derivative of the green. Well, the derivative of g is just going to be g prime. Everything else stays. Times, now the derivative of the pink or purple, that's h prime. That's the derivative. I can't combine like terms or anything because I don't know what the actual function is. I don't know what g of x is. I don't know what h of x is. So that's as far as I can go. But now I can plug in 5. Everywhere I see an x, I'm going to plug in a 5. Okay. So I have g prime of h of 5. So I got to go find h of 5. Look at the table. H of 5 is 3. So this guy is going to be 3. Still has a g prime out in front, though. Still has a g prime out in front. H prime of 5. H prime of 5 is negative 2. Okay. G prime of 3. What is G prime of 3? Not 18. G prime of 5 is 6. That's what they told me earlier. What's G prime of 3? We don't know. If not possible, state what additional information you need to find the value. Well, I can't solve this, so I would say I need the value of G prime of 3. If I had that, I could solve it. Was it possible? Okay. All right. Okay, so try letter C on your own. Try letter C. Same table, same everything. I need you to find f prime of 5. So you have g of x divided by h of x. Find the derivative. That's quotient rule. Low times the derivative of the high minus the high times the derivative of the low, all over the low squared. Okay, so let me plug in 5 everywhere I see an x. Okay. Now I'm going to go to my table and figure out what all of those values are. So let's see, h of 5 was 3. So on top I have 3 times g prime of 5 is 6. So I have 6 here minus g of 5. G of 5 is negative 3 times h prime of 5. H prime of 5 is negative 2 over h of 5 squared. H of 5 is 3. So it'd be 3 squared. Okay. So on top, we get 18 minus 6 over 9. So that's 12 over 9, which reduces to 4/3. 4/3. Okay. All right, last one. Okay, so again, same thing. We got to find that, f prime of 5. Okay, so it's g of x times g of x times g of x itself 3 times. Right. Well, so what this means is g of x times g of x times g of x. We could, I mean, you could, we couldn't use product rule, because for product rule we only have when you're multiplying 2 times. Then we have a third. So what do we do there? So we can't actually use product rule. Or you could actually use product rule, but you would have to do this. You would have to put 2 of them together and then multiply it times the third. So you could use product rule then. I think the easier way to do it, though, would be just to use chain rule from the very beginning, because chain rule, you have something to the third power, and then you have something in the middle. So chain rule says derivative of the green. Move the 3 to the front, rewrite that something, take away a power. That's the derivative of the green. Now find the derivative of the inside, g prime of x. Okay, that's the derivative. Plug in 5 everywhere you see an x. Okay. We always do inside the parentheses first. So I'm going to start here. That's the first thing I'm going to do. So the g of 5, if I go back to my table, g of 5 is negative 3. So this guy in here is going to be negative 3. So I have 3 negative 3 squared times g prime of 5. Let me change that. What is g prime of 5? G prime of 5 is 6. Okay. Next, I do exponents. So negative 3 to the second power is 9. Then you have just all multiplication left. So you get 27 times 6, or 54 times 3. Let's see, 27 times 6 is 162. Done. Okay. So that's finding derivatives from a table. It's the same thing. Same rules. We use the same rules. I didn't make up new rules. It's just there weren't functions. So I had to use generic functions. These are generic functions, g of x, f of x, right? It's the same type of stuff, okay? All right, so I'm not gonna give you the assignment right now because I wanna do some more practice. So if you don't have any room on that paper, find your notebook or find a paper, something like that. I wanna give you a few more problems that you guys can work on your own right now, and then we'll push the assignment to tomorrow. I won't assign it till tomorrow, but I want to do some practice with the 30 minutes or so that we have left. Okay, so we'll call this extra practice. Okay, let me find some problems here. Okay, so let's try this one. Let's see. y equals x over square root x squared plus 1. So you're going to find y prime. Okay? Try that one. I'll give you some time to do that one. Find the derivative of that. So there's two ways to go about this. The first way is use the quotient rule, right? Use the quotient rule. That works, right? To use the quotient rule, all I would do is, before I would use the quotient rule, is take away this guy here and change it to a 1/2. And use the quotient rule. That works. You can do that. Or you can move the bottom to the top by using negative exponents and doing it that way. It's preference. It's 100% preference. There's not one way that's better. Personally, I'm telling you personally, from teaching this class, I prefer, anytime I can avoid having to use the quotient rule, I prefer to do that. That's just preference. The quotient rule, I've just seen a lot of mistakes happen with the quotient rule. Because there's a lot of things going on. You have a top and a bottom. You have a lot of different parts to it. I prefer to use product rule as much as possible. So I use the green. Do you have to? No. You're going to get the same answer. Okay. So that's what I would do. I'd use the green. Again, is it wrong if you use the yellow? No, not at all. If you use the quotient rule, it's not wrong. There's nothing wrong with it. As long as you did it right, there's nothing wrong with it. Okay. So I'm going to do the green. So the green means product rule. So I have x times this guy to the negative 1/2. So the product rule says the first one times the derivative of the second. So the first one times the derivative of the second. Well, the derivative of the second is a chain rule problem. So I have to move negative 1/2 to the front, keep everything the way it was, subtract a power, you get negative 3/2. Plus. Then the opposite. The derivative of the first, which is just 1, times the second, the way it is. Okay? That's technically the derivative. All right? Clean it up a little bit. So over here, multiply these two guys, so we get negative 1/2 x. Actually, you know what? Let me do it this way. Negative 1x, 2 on the bottom, and then I'm going to have this guy on the bottom. Okay. Over here, I'm going to have 1 on top, and I'm going to have this guy on the bottom. Okay. Done. If you use quotient rule, this is what you got as an answer. If you use quotient rule, you got 1 fraction instead of 2. And you would have gotten, where is it? 27. You would have gotten 1 over that instead of this. And if need be, I could do that. I could make this look like that. It would involve some algebra, but I could do that. Mm-hmm.
'Cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for airplanes, 'cause, like, in the first part, like, for
Yeah. This guy right here? Yep. Oh yeah, I forgot to tag on that 2x. Yeah, sorry. Yeah, you're right. So I should have tagged on the 2x there. Yeah, you are correct. So it would be there would be an x squared there, right? Yeah, that was a mistake. Because then these two guys would cancel out, so make a -1, and then x times x is x squared. Yeah. Okay. The only thing with this is a multiple choice question, and if you see this, both of these will not be A and B. They will only one of them will be there, right? So here's the thing: if this answer is there, you're going to have to get from here to here. Even if you do it right, you got to get there. That's the hardest part, not the calculus part. But I get students that get this answer here, and then they look at A, B, C, D, and this answer is there, but they're like, how do I that's where it happens. Okay. So this is what I'll tell you. If I were to see this problem here on a test, and all of the ABCDs look like this, one fraction, use the quotient rule. Use the quotient rule. Quotient rule will give you one fraction. If you see all of the ABCDs look like this, that's because they use the product rule. That's why there's that plus in the middle, right? The quotient rule only has one fraction. That's where this one fraction comes from, right? The product rule has a plus in the middle. That's where that plus comes from. So it just depends on which rule they used. Mathematically, it's correct using any rule, but on a multiple choice test, you need to match, right? So if they have a bunch of things that look like this, where there's a plus in the middle, they use the product rule. If there's a bunch of things that look like this, where it's just one fraction, they use the quotient rule because the quotient rule only has one fraction. Okay, that's what I would do. That's what I would focus on. Okay, that's how you can tell what they used. If it's one fraction, they use the quotient rule. If it's two fractions, they use the product rule because of that plus in the middle. Okay. All right. So let me get you another one. Let's try another one. Let's try trig one. Okay, so let's try this one. H of x equals sine of 2x times cosine of 2x. Okay, find the derivative, find h prime. Okay, so we have two functions multiplied times each other. We have this guy right here and this guy right here. Product rule. So the first times the derivative of the second. Well, the derivative of the second has two layers. It's got an outside layer and it's got an inside layer. So I have to find the derivative of the green and then to find the derivative of the yellow. The derivative of the green is negative sine 2x times the derivative of the yellow, which is just a 2. Okay. And then the opposite, derivative of the second. So the second rewritten times the derivative of the first. Well, it's the same thing here. It's got an outside, that's sine. It's got an inside, that's 2x. So derivative of sine is cosine 2x times the derivative of the inside, which is 2. Okay. So I have these two guys. I have a -1 here and a 2, so I'm going to move a -2 out in front. And then they're both the same. So you could just say squared. Same thing over here. I have a +2 I can move in front, and then okay. All right. Let's see. Let's try another one. All right, let me give you one that I was talking about earlier. I'll give you an example of a multiple choice question where here's a possible multiple choice question right here. I can't make it any bigger without having. So you see x minus 3. Actually, you know what? I can make it a little bigger. Okay, so we got x minus 3 divided by 3x to the fourth plus 2 to the -2. Okay, so we got to find derivative of that. And then so there's two ways I can do it. I can do it as is and use the quotient rule, or I can move this guy up and make it positive, right? And use the product rule. Either one's mathematically correct. So which one should I use? Well, I'm going to use the one that most likely is what they're looking for. So you look at A. The answer for A is right here. The answer for A is right here. That's one fraction. The answer for B is right here. That's one fraction. The answer for C is not a fraction, but there's no plus in the middle. So it's not product rule. And then the answer for D is one fraction. So that means they use the quotient rule. So that means for this guy, I would use the quotient rule. Okay? To match, to best match. Okay? Try that one. Try this one. This is a good one. Try this one, see what we get. Last one we'll do. This is the last one we'll do. Use the quotient rule. Use the quotient rule to try to match one of A, B, C, D. A used the quotient rule incorrectly because on the bottom you're supposed to square it. They didn't square the bottom for A. It should be squared. Okay. B didn't put the bottom one correctly. It's supposed to be the bottom squared, not the top squared. C did it correctly. Low times the derivative of the high, the derivative of the high would just be 1, so that's why, and then subtract all of that. And then the bottom one didn't use it, had no bottom. Had no bottom. Okay, so that's why C is the only one that could work. So eventually when you get down there, so on the bottom, you're going to have 3x to the fourth plus 2 to the -4. So that's why it moves up. That's why number 3 doesn't have a bottom, because the bottom is negative, so it would move up. Okay, and then when you combine like terms and everything, that's what you would get. Okay, on a test though, I would test, you wouldn't have the first step. The first step would be gone. All that would be there was the answer. So that just the answer there. Okay, that's all that would be there on test. But I put the first step on there just because we're not there yet. Okay. All right, guys. Okay, so tomorrow I'll give you the assignment. I'll let you guys work on it. We're going to take a few days for that. All right.